Hey, good afternoon. Tony Williams here with University College at University of Denver. I've just finished designing a course with Carrie for EPM 4230, Alternative and Renewable Energy. Is the name of this course, or I guess a redevelopment of the course, and I'm the SME. I'll probably deliver the course later in 2022. So just wanted to go through it real quickly as the SME and talk about what was behind each course module and let you in on some of the strategies that I've been thinking about as we put this together. So basically, it's a graduate level course to understand renewable energy resources and technology. Also, understanding what baseload energy is, and I want the students to be able to articulate renewable and alternative energy strategies, and I want them to explain the benefits of renewable energy policy. I want them to understand the tradition of fossil fuels and the generation of power from fossil fuels as that relates to climate change, and what greenhouse gases are. Also, kind of the largest discussion item in renewables now is storage. So I want them to understand utility scale battery storage and some of the chemistry there, and what we're doing from not only a technical perspective but from a policy perspective as well. So, we'll look at renewable energy sources and technologies and define their place in the energy space. With the decline of fossil fuels and the advent of the accepted reality of climate change. We'll also discuss human activity and all energy sources and their impact on the environment, while noting renewable energy is no exception to this rule, and each source has its own trade-offs. However, I want the students to understand the devastating impacts of fossil fuels and some of the reduction of water and land use and air pollution and wildlife and other very provable scientific facts with regard to greenhouse gas emissions. But also want them to understand and learn that there are many unsolved problems with renewable energy manufacturing and sources and products and disposal and explosivity, especially with batteries and that kind of thing. So I want to kind of take a look at all of that. So the first module will just kind of start off at the base level of energy source fundamentals. What are fossil fuels? What is renewable and alternative energy? I really want the students to understand base fuel energy here and fossil fuel resources and where all that comes from, and what exploration is, what development is in the traditional oil and gas industry, and why we have been where we are for so long, and where in the future we may be going with new renewable energy policy here. So we'll look at in this first module, like I said, what baseload power is and why that argument with regard to renewable energy is such an important one, with whether or not we can actually have renewable energy baseload power, since we rely so heavily on fossil fuels right now. So most of the articles and videos are really around those questions, and I want to kind of focus on what are the top 5 renewable energy resources that we're seeing: solar, water, wind, and a few others, and how and which ones are being developed the quickest. I'd like for them to be able to describe the use of energy and define renewable and non-renewable energy, understand the benefits and disadvantages of renewable energy, and the general characteristics and some of the fossil fuel arguments also with regard to batteries and the viability of baseload renewable energy. And then week 2, we'll dive a little deeper into really technical discussions about storage technologies and resources and what large-scale renewable energy storage looks like. Very, very young technology. We don't seem to have the chemistry figured out yet for some of the best and most effective storage battery sets, and so this is something we want to talk about as well. And I've listed, I think, some pretty good, battery storage system technologies, even beyond lithium ion, and what type of large storage facilities are being built, and can batteries really solve the problem, especially for solar energy, as we begin to develop larger and larger solar farms. So week 3, staying with renewable and alternative energy, I really put together more alternative energy source discussions here. I want them to dive into biomass and some of the smaller, even hydrocarbon-related energy opportunities that still exist beyond wind and solar. What is clean, what is frequently claimed clean but is not as an alternative energy source. Really think about what else is out there, and from biofuels to hydro to hybrid power systems, solar as kind of a back burner, and then begin to start thinking about microgrids, and could all these different alternative sources create a microgrid, and how would that work? And in addition to wind and solar, and kind of lead them into beginning to think about nuclear energy. Wait a minute, is that an alternative source, and is it viable? And we'll get to that one in a minute. So week 4 continues into biofuels and some remaining hydrocarbon alternatives to the traditional fossil fuel power development that we're seeing right now. And so I want grad students to really look at what type biofuels are considered viable now. And we've seen, whether ethanol is a biofuel or not, whether recycled grease and oils are a good biofuel. Let's discuss, is there a market for that? What's the cost analysis, and is that something that should also be considered an alternative source? And then look at it also based on just traditional hydrocarbon exploration, development, refining, and delivery. Is that a finite source? Do we need to have all of this activity? Is this well researched? Is there good evidence to prove that we need to change our base load? And that's why I wanted to write maybe about a 15 to 2,500 word paper here on the viability of alternative energy, specifically biofuels, and evaluate the trade-offs of biofuels, and look at real-life applications, and really give us some discussion on whether or not there's viability in biofuels as an alternative source. And then in week 5, I want them to look at nuclear energy. This is a source that's coming back pretty strongly, of course, with Fukushima and other disasters or potential for disasters. Nuclear energy has always been on the back shelf, but Bill Gates and others have taken a good hard look at it. We're seeing new technologies and closed loop waste streams, which may be really interesting, but really want to add to the discussion here about safety and security and these waste streams, and the viability economically of building a large power plant, and the permitting process that seems to take so long. There hasn't been one here for years. And then contrast that with France or other countries that pretty much rely on nuclear energy as their base load, and talk about that in addition to nuclear fission and fusion, and how uranium fuels work in the process, and what are the considerations with uranium and all of the terrible plutonium resources that have caused us waste stream issues for so long, and if that would occur again. So just dive into nuclear energy a little bit is the idea here, and think about comparisons to renewable energy from a clean power perspective. I mean, nuclear seems pretty clean if we can figure out how to deal with the waste stream, and may not add to some of our climate change, certainly not our greenhouse gas issues that we're suffering from now. And then finally, think of it from a political and policy perspective. What's the policy currently of this administration with regard to nuclear energy? What might be the policy going forward if we can't really create a wind and solar, say, base load? Then moving into week 6, pretty simple discussion on transmission and distribution of electrical energy, so that the students can understand how exactly we transmit electrons. Obviously, on our large high voltage towers, it's transmission, and then the distribution on the smaller wooden poles or underground lines that they may have or know about in their neighborhoods. And so who are we transmitting to? Who are we distributing to? Who are the largest customers of utilities that do transmission and distribution? And how are those projects developed, and that kind of thing. So I want them to be able to explain how power generation starts, maybe at a gas plant, a coal plant, a large wind, 200 megawatt wind farm or something like that, where transmission starts. How difficult is it to even develop transmission projects and develop distribution across a neighborhood or wherever else? And who's driving that? Is it commercial or residential customers? And then how does the Public Utility Commission work with each of these different clients that they have in the sense that they are supposed to be representing, the residential ratepayer and the commercial ratepayer? Or are they working with large investor-owned utilities? And how do utilities make their money and then add it back to the consumers when they build large transmission and distribution lines? Just really understanding the whole kind of process of developing transmission and distribution, and how they need to get electricity to their customers. So also look at some of the varying utility types. Understand what cooperative utilities are on the smaller scale, and how they buy electricity from each other and generate power, or don't in any way, and just serve smaller communities. So understand what a co-op is, understand what a owned utility is, understand what a public utility commission does, and are they effective in power transmission and distribution, and do they set rates? Who sets rates, and where do those costs come from? So a little more into the economics of utilities and the delivery of electricity in week 6. And then in week 7, just kind of change gears a little bit and start talking about sustainability considerations in renewable energy technologies. Specifically, what are the waste streams associated with the larger renewable manufacturing technologies and products? Wind turbines, where do they go when they're old? Are they recyclable? What's going on, for instance, with solar panels? What is China do with solar panels as they have emerged as the largest producer? Do they recommend recycling of their solar panels? Can you recycle a solar panel? And then, have the students recommend sustainability policy for renewable energy waste streams. Specifically, as we continue to develop battery storage, we've got a lot of chemical waste streams that are of concern right now. How are we dealing with that in precious minerals, mining, and other kind of the unintended consequences of developing batteries and solar panels and wind turbines and the like. So we really want to look at waste streams and are they being mismanaged? What's the cost effectiveness, even when you include some long-term sustainability cost or recycling costs for renewable energy? Is it still cost effective when compared with fossil fuels per kilowatt hour, maybe? So really deep dive into that type of waste stream discussion around renewable energy. And here also we're asking them to write a paper of a couple thousand words on some of the waste stream matrices and the management of renewable energy. Specifically, put together a matrix that shows all the different potential waste streams that might be associated with, the top renewable energy technologies, wind and solar, and tick off which ones we would have to contend with to develop a solar panel or to develop a clean wind farm. And then what are the recycled pieces and parts once that wind farm comes down, for instance. And then in week 8, we'll move into greenhouse gases and fossil fuels. Lots of reference information here. So what we're really trying to focus on, though, is with regard to climate change and weather events and the discussion of climate change, what's the scientific evidence that we do have and that we do trust that fossil fuels contribute to greenhouse gases? And what does that mean, really? And how is it released into the atmosphere? And is it too late to change it? And I want them to think from a policy perspective, too. What's the next great policy considerations for the elimination of the majority of greenhouse gases? Not only from generating facilities like coal plants or gas plants, but transportation, one of the main contributors to greenhouse gas. How do we change that and improve that? Not just the generation of fossil fuels, or the development of fossil fuels, but also the refined fuel that we burn in our mostly gasoline-powered cars. So the articles and the videos will be similar to that, and felt like there'd be a good chance here to jump into talking weather events a little bit too and how they're connected, but really wanted to make the point in this module that really want to see evidence-based discussions. What did you find? What were your references? Was it a NOAA or a NASA reference? And what's the research? And talk about polar ice caps melting and give us a little bit of data there whenever you use that in your discussion, so that at the end of this module you'll be able to explain how fossil fuels contribute to greenhouse gases released in the atmosphere. For instance, to a intelligent 8-year-old or a very smart science savvy high school kid, and then an educated and skeptical but open-minded oil and gas career employee. I mean, what is our current policy? Are you considering your tone and your word choice? Are you, walking along with them, as they say, to discuss climate change and greenhouse gases and fossil fuels? And can you make your point without getting emotional on this issue, and that you can provide evidence to support your recommendations, and especially as you hopefully will develop policy later around this very volatile topic. And then week 9, that rolls into our current United States energy policy and then global implications. So with the new administration, I wanted the students to explain what our current energy policy overall is. What is the United States energy policy today? And what implications might our energy policy have on other countries? And so analyze that, talk about fossil fuel dependency, the new focus on renewable energy, and then really, look at the developing policy and whether or not you believe it's a good policy, and add to the discussion boards in this way. Not only for fossil fuels, but the new development in renewable energy, and with the new infrastructure spending bill that should pass in some form. How much is that related to renewable energy development? And how much does that really become part of our U.S. energy policy? And how will the fossil fuel industry, be affected? So that's what I wanted them to look at here from a current U.S. policy perspective. And then the last module, just to wrap it up, is kind of pulls everything together to get them to talk about current status of renewable energy and alternative energy policy. So they've thought about U.S. policy. They've thought about the a base load of fossil fuels, which is the current way we manage the development of our power and the distribution of our power. Now, looking forward, what type of new renewable energy policy is being developed, and what might it look like in the future when perhaps base load is derived from renewable energy? So, think about storage site implications. Think about the larger carbon footprint users of power, like large data centers. Can we power them with a microgrid that's all renewable energy? Does that provide the kind of redundancy that they need in their IT processes? Is that possible moving forward? Really, really critical thinking and critical questions around whether or not we can ever get to a baseload renewable energy platform, and how long that will take, and what that policy will look like. So that's about it for the course. If you've got any questions, please call me or contact me at tony.williams@du.edu, and thank you very much.